All right, welcome. Today we are jumping headfirst into a theory that's, well, pretty out there. We're talking about an argument so radical it claims to flip 300 years of physics on its head. The idea is that the very way we understand light, its wavelength, its frequency, has been completely wrong since the days of Isaac Newton. So let's dive in and see where the author claims this all went wrong. So here it is, right out of the gate. This is the opening shot from the author of our source material, Mathis. He's not just suggesting a tiny little correction here. He's proposing that one of the most foundational concepts in all of physics has been assigned completely backwards.
So that's the big question, right? Is it even possible that our entire understanding of light is built on a simple error made centuries ago? To figure that out, we've got to unpack this argument piece by piece, starting from the very beginning.
Okay, let's get into it. Section 1, the original sin. Now, according to the author, this whole mess didn't start with some super complex experiment or a mathematical error. Nope. He says it all began with a simple analogy, and one that he claims was fundamentally flawed from the start, comparing light to sound. Okay, so check this out. Here's the author's historical case. Back in the 1670s, right, everyone understood that sound was a wave moving through a medium, like air or water. So when brilliant minds like Newton started to really dig into light, they just kind of borrowed that idea. They started drawing light as a sine wave, just like a sound wave. The problem, as the author points out, came way later, in 1887. The super-famous Michelson-Morley experiment proved there was no ether, no medium in space for light to travel through, and physics accepted this. But, and this is the absolute crux of his argument, they kept the sine wave diagram. They threw out the physical medium, but kept the drawing that only makes sense if a medium exists.
And that really is the heart of his historical claim. He's basically saying that for hundreds of years, when scientists have talked about wavelength, they haven't been measuring a real, physical property of light. They've been measuring a feature on a convenient drawing, a drawing that he says doesn't even represent reality.
Okay, so Section 2, the new model. If the old sine wave diagram is wrong, then what are we supposed to use instead? Well, the author proposes we just get rid of it entirely. He wants us to swap the idea of a sine wave for the idea of physical spin.
Now this slide is really cool because it puts the two ideas side by side, and you can really see just how different they are. In the standard model, a photon is this abstract, massless point particle, and its wave is some kind of disturbance in a field. But in the author's model, a photon is a real, physical thing with size and mass, and the wave is just, well, it's the photon spinning. This changes everything. Suddenly, energy isn't tied to frequency anymore, it's tied to the photon's actual physical radius. A bigger photon has more energy. And wavelength just becomes the photon's radius, while frequency becomes how fast it's spinning.
And here is where it gets, well, explosive. In the standard model we all learned, long wavelength red light is low energy and short wavelength blue light is high energy. This new model completely flips that on its head. A larger radius, which he's now calling the wavelength, means more energy. This puts his theory in direct head-on collision with centuries of physics. So how on earth does he defend it?
Section 3. Rereading the evidence. The author claims his proof has been hiding in plain sight this whole time, right inside the data from one of the most fundamental experiments in all of optics, the interferometer.
So first, let's just do a quick refresher on the textbook explanation. An interferometer splits a beam of light, sends the two halves down slightly different paths, and then brings them back together. Where the waves line up, they get bright. Where they cancel out, they get dark. And this creates a pattern of light and dark bands we call fringes. This pattern is believed to be a direct measurement of the light's wavelength. Simple enough, right?
Well, the author throws that whole idea out the window. He argues it's not wavelengths interfering at all. Instead, he wants you to picture these photons as tiny spinning clocks. Because one path is a little longer, when they recombine, they're out of sync. It's like half the clocks point to 2 o'clock while the other half point to 3 o'clock. He calls this a spin phase gap, and he claims this is what actually creates the fringe pattern we see on the screen.
Okay, this right here is the absolute key to his entire argument. So let's walk through his logic step by step. Let's say you take a photon that's spinning really, really fast, what he would call a high spin frequency. You send it through the interferometer. Because it's spinning so fast, that little path difference creates a bigger phase gap. It gets more out of sync over the same distance. Now this larger phase gap, he argues, produces a wider, more spread out fringe in the final pattern. And what does mainstream physics see when it sees a wide fringe? It calls it a long wavelength.
So according to the author, the experiment is assigning a long wavelength to what is actually a high spin frequency. The variables are, in his view, completely backwards.
So, if he's right about the interferometer, what happens next? Well, this brings us to section 4, the takedown. This is where he claims the foundational math of photon physics just completely falls apart.
He starts with one of the most famous equations there is. The speed of light equals wavelength times frequency. He says this equation is just fundamentally broken. It was built to describe field waves, like sound, and it has no way to account for a particle whose physical size, its radius, and therefore its energy, is actually changing, which is totally central to his model.
And from there, the argument gets even bigger. The author claims that Planck's constant, one of the fundamental constants of the entire universe that connects a photon's energy to its frequency, isn't fundamental at all. He calls it a mathematical fudge factor created for one reason and one reason only, to make the broken sine wave model fit the data from experiments.
So if the standard model is broken, just how broken is it? Well, according to the author, the standard energy calculation is off by this much.
That's right. He claims the standard equation for a photon's energy is wrong by 6%. But, and this is a really clever twist, he's not saying the experimental data is wrong. No, he says the equation is what's wrong because it's failing to account for a hidden variable, the energy of the background charge field that exists right here on Earth, where we do all our experiments. That 6%, he says, is the energy of the field, not the photon. And here are his proposed new equations. Now, we're not going to dive super deep into the derivations, but just look at what's going on. Two huge things jump out immediately. Planck's constant is just gone, and a photon's energy and mass are now directly proportional to its physical radius, r. A bigger particle has more energy. It's a purely mechanical, physical model. All right, section 5, the ripple effect. Let's just step back for a sec. What would it actually mean for science if this incredibly maverick theory turned out to be right? Well, the implications would be absolutely staggering. We're not talking about a minor adjustment. This would be a complete and total paradigm shift. 300 years of wave mechanics would have to be thrown out and rewritten as spin mechanics. Core theories in optics and quantum electrodynamics would need a total overhaul. Even our most basic explanations for things like why the sky is blue would be completely reversed. And all those charts you've ever seen showing red light is low energy and violet light is high energy, yeah, they'd be flipped completely upside down.
And that leaves us with a final, really fascinating question to chew on. The current model, it gives us equations that produce unbelievably accurate predictions, right? Even if the underlying picture is, as many physicists will admit, pretty strange and not very intuitive. The author, on the other hand, is proposing a model that he claims is mechanically simple and logical, but it would require us to just throw away centuries of established theory. So it makes you wonder, what's the ultimate goal of science? Is it an equation that works, or is it a model that makes sense?